Right, good day everyone. My name is the Calculus, and I'm going to be taking you on quadratic functions and quadratic equations. Okay. Now, in maths, this is one of the topics that, as a mathematics student or a student who is going to, one time or the other, indulge in calculations, both in maths and physics, you would need to have an idea of quadratic equations. It's very, very important. Okay. Now, first of all, we'll start with a quadratic equation. Okay, and I'm going to talk about the roots of a quadratic equation. Okay, how we can determine the type of roots that a quadratic equation should have, and the kind of questions that will come around this area that involves the roots of a quadratic equation. Okay, now a quadratic equation has a general form. Okay, now this is the form that when you see it, you would know that what it talks about is a quadratic equation. What is this form? Every quadratic equation has a form ax squared plus bx plus c being equal to 0. Okay, like I explained in my previous videos, I told you what the a stands for. The a stands for the coefficient of x squared, that is to say the number that is standing close to x squared. Now b talks about the coefficient of x, okay, that is to say the number that is actually standing close to x. Okay, then c is your constant value. Okay, c is not a variable. C would definitely just be a number if you have it in the equation. All right, now if you want to find the value of x, this is a degree two equation. Okay, a degree two equation means that the highest power of your known x is 2. Okay, so it means it's a degree two equation. Now, how do I solve these equations? There are different methods to solve this equation. We have about four different methods that you can use. We can use the factorization method. We can use the general formula method. We can use the graphical method. Okay, then we can use the completing the square method. So four of these methods can help you solve for the values of x. Okay, but in this video, I'm going to major on the general formula method. Okay, then from there, I will tell you about the roots that are akin to general formula equations. Okay, how to process the roots from general formula method. Right now, if I wanted to obtain the value of x, okay, I want to find the value of x here. What do I do? The first thing I'll do is to take this constant value c to the other side. Okay, how do I do that? This means I'll be having ax squared, okay, plus bx plus, okay, becomes equal to minus c. Okay, so if I have moved c to the other side, okay, now the next thing here is to make x square unity. Okay, to make x squared unity. How do I make x squared unity? I can make x squared unity by dividing through by the coefficient of x squared here, which is a. Okay, now how do I do that? This becomes, I'll divide here by a, divide here by a, and divide here by a. When I do this, I'll be left with x squared plus b over a of x is equal to minus c over a. Now, at this point, I'm going to be doing something very important. Okay, I'm going to take half the coefficient of x. Okay, that is to say, multiply the coefficient of x, which is b over a here, by half. All right. So if I do that, I'm going to be having 1 over 2 of the coefficient of x. Okay, take half the coefficient of x. Now square it. Okay, square it. So let's square it. If I should square it, I'll be having this squared. Then I'm going to add to both sides of the equation. So this value, the value I'm going to have here, I'm going to be having b over 2a all squared. The value I'm going to have here, I'm going to add it to both sides of this equation. The equation here. Okay, I'm going to add it to both sides of this equation. So let's do that. So if I add to this side, I'll be having x squared plus b over a. Okay, then adding this, I'll be having plus b over 2a squared. I've added to the left hand side. Now let's add to the right hand side here. We'll be having is equal to minus c over a. If I add this to the left hand side, I'll be having plus b over 2a and a squared. Now, there's something I will show you shortly. Okay, if I should take the squared here, okay, if I take x here, that is from this x squared, I pick x, okay, I pick this sign here, and I pick this value here, it is going to give me something I want to show to you. Okay, that's what I mean. If I pick this x here, then pick the sign that is close to b over a x, pick the sign plus, then pick this is still the value under the square, okay, b over 2a, then square it. It is going to give me the same value as this. It's going to give me x squared plus b over ax, okay, plus b over 2a squared. Now it works every time, okay. In maths, this is very correct. This is very, very correct, okay. So this is something that you can try that, you can try to expand it yourself, and you see that it gives you exactly the same value, okay. This is equal to this, okay. Now it means that when I see this, I can easily replace with this, okay. So in this equation, where I see in this equation here, in this equation, where I see x squared plus b over a of x plus b over 2a squared, I could replace it with this. So let's do that. If I do the look at how I'll be having this, I'll be having, so in this equation here, everything that's going to be here is going to be plus x plus b over 2a squared. Now what is it equal to? It is equal to minus c over a plus b over 2a squared. Alright. Now we can actually add this up. We can add this up. So this gives me x plus b over 2a, x plus b over 2a all squared is equal to the same thing as minus c over a plus. Now if I square b, I'll have b squared. I'll have b squared. So this gives me b squared over, if I square 2, I'll get 4. 4. If I square a, I'm going to have what now? A squared. Okay. So let's add up these two values. Let's see what happens. So I'm having x plus b over 2a or squared is equal to, the LCM here is 4a squared. The LCM is 4a squared. Now if a should go into 4a squared, we have 4a left. So 4a multiplied by minus c gives us minus 4ac. Now come back again. 4a squared into 4a squared, okay, gives us 1. Then 1 times b squared gives us b squared. All right. So now at this point in time, I want to look for x. Okay. Now what I'll do here is very, very easy. I'll just say, okay, to find x, first of all, the first thing I'll do is to make x plus b over 2a stand alone. So I'm going to be having x plus b over 2a. It is standing alone now. So this will now be on the right hand side plus or minus square root of, let's just rearrange it to be 4b squared minus 4ac divided by 4a squared. Okay, this is what I have. Now, why did I call this squared? Because I wanted to make this term here stand alone first. So I have to, if I move this square to the other, this square to the other side, it becomes square root on the right hand side. But you remember, you have to add your plus or minus. Okay, this tells me that if I should quickly show you this. Okay, when you have x squared being equal to 2, and you want to make x subject, now x is going to be plus or minus, okay, root 2. This is the best way to write it. It should be like this. Okay, this is the best way to write it. So I did the same thing here. All right. So now at this point, this is what we have that x plus b over 2a, okay, is equal to plus or minus, that's going to be square root of b squared minus 4ac divided by square root of 4a squared gives us, square root of 4 gives us 2, and square root of a squared gives us a squared, okay, gives us a, square root of a squared gives us a. So now make x solve. I'll be having that x is equal to, take this one to the other side. I want to make x solve it. So I'm moving b over 2a to the crossover to the other side. So it becomes minus b over 2a plus or minus square root of b squared minus 4ac divided by 2a. What is the LCM here? The LCM here is 2a, so x therefore is equal to, take the LCM. LCM is 2a, right? Now 2a into 2a gives us 1. Then 1 times minus b gives us minus b plus or minus. 2a into 2a gives us 1. 1 times square root of b squared minus 4ac gives us square root of b squared minus 4ac. Okay. Now finally we have arrived at the value of x. Okay. Now what it tells me here is that finally x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2. Now this expression, this term you have here, this expression here is called the general formula, okay, method. Okay. Now if you want to solve any quadratic equation of this type, okay, where a is the coefficient of x squared, b is the equation of x, and c is the constant value, okay, if you want to solve any of these equations, you could simply just apply this formula, placing your A where you see A, your B where you see B, and your C where you see C. Okay, when you do that, you're going to find the value of x. It's very, very simple. Now, what does this plus or minus tell you here? This plus or minus simply tell you here that what you have two different roots. Okay, you have two different roots right now. Okay, so it means that the first root, let's call the first root x1. So that will be taking, okay, minus b plus square root of b squared minus 4ac, the guy divided by 2a, then x2 x2 is actually equal to minus b. Now we're going to pick a minus here this time. No, we'll pick plus the first time. So we're going to pick a minus this time. So it becomes minus square root of b squared minus 4ac divided by 2a. Okay, so these are the two roots of the equation. Okay, the roots of the equation is going to be what now? X1, which is this, and x2, which is this. Okay, all right, now we have seen that after finding x from this equation, ax squared plus bx plus c is equal to 0. After finding x, we have seen that x is going to be minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay. Now, one of the mistakes that you're going to make if you're not careful as a student is thinking that this all divided starts from here. Please don't make this mistake. Okay, this all divided by starts from here. Okay, it covers everything here. All right. Now the next thing I want to talk about is we want to talk about how to determine the nature of the roots of a quadratic equation. Now we know that it's quadratic, the answers is going to just be 2. Okay. Now, but when we have trinomial equations are degree 3 equations. Again, as we say, when I say degree 3 equations, the highest power of the unknown x is 3. Okay, we also have the fourth degree 4 equation. We also have the degree 5 equations. Then we're going to do that under the topic called polynomials. Okay, but we're going to just stick to quadratics in this section of the class. Now, listen. Now this term, this expression here, this expression b squared minus 4ac is termed discriminant. Okay, it is called discriminant. Okay. Now, why do we have to give this term discriminant? Because it uh, differentiates the roots for us. Okay, it tells us about the difference in the nature of roots. Okay, of the quadratic equation. So now in most cases, you could say that we call b squared minus 4ac equal to d. D stands for discriminants. Now, depending on what the value of b squared minus 4ac is, we could have real and distinct roots. Okay, that's the first thing. Real and distinct roots. So we have, listen, we have real. The first one we talk about is the real and distinct roots. Real and distinct roots. Okay, now your real and distinct root simply gives you a type of quadratic equation that has the two roots to be completely different. That's one. Okay, that's to say it is distinctive. Okay, they are different. Then they are real, which means we have a normal number or a natural number. It could be 1 minus 1, 2 minus 2. Okay. Now, how do I know that I'm going to have real and distinct root? That's the roots where we have that x1 is equal to m and x2 is equal to n. So two different roots, two distinct roots. Now, how do I know that the roots are distinct and the roots are real? Remember, b squared minus 4ac must be greater than 0. So when b squared minus 4ac is greater than 0, okay, we have two roots that are real and they are different. Now, the next thing again is we can also have when the roots are real and equal. Okay, so we have real, and equal roots. Okay, real and equal roots. So the roots are going to be real, the roots are going to be equal if b squared minus 4ac is equal to 0. Okay, now what kind of roots am I talking about here? A kind of situation where x1 gave us m and x2 still gave us m. So the roots, although real, they are not distinct. They are the same. Okay. Now, two of them together, okay, it was in most questions, okay, I could decide to combine roots. Okay, when I could say real roots. Okay. When the roots are real, what does that tell me? If the roots are real, they could be real and distinct. They could be real and equal. Real and distinct, real and equal. So when it's real and distinct, the roots are different. When it's real and equal, the roots are the same. Now see, so together these two can be combined to say real roots for real roots, okay, for real roots. Remember that b squared minus 4ac should be greater than or equal to 0. Please listen, you don't have to forget this. You shouldn't forget this, okay? Because there are most questions I will show it to you in this section that there are most questions that will take you down to this. Now, this is an inequality equation, an inequality symbol, just as this, okay? But this one is an inequality symbol greater than or equal to. Now, so this third guy, okay, is just a combination of real and distinct and real and equal. Okay. Now, the last type of root is when we have a complex root. Now, when do I have a complex root? I will have a complex root when b squared minus 4ac gives me a negative number. When b squared minus 4 gives me a negative number, remember that we are having a square root here. Okay, so square root of a negative number, okay, gives me an undefined term. Okay, a term that cannot be defined. It gives me a complex number. So that is why, well, in my section where I will teach you about complex numbers, I will teach you about what we can use to express square root of a negative number. I will show it to you. Okay, so just stay tuned. Remember to follow me on my YouTube channel. Okay, the Calculus Academy. Okay. Now I'm going to be dropping videos there that they're going to help you. They're going to help you a lot. Okay. Now you can see how I break this thing down. You can just follow me step by step, and your journey to a success, your journey to being a success in maths, it's so certain. Okay. Now the next type of root we talk about is the complex root. Okay, complex root. Now, the complex roots, okay, are roots that have complex numbers. They are not real numbers, complex. Okay, and when do I have complex roots? When your b squared minus 4ac is now less than 0, so it gives me a negative number. I'm going to be having a complex root. Okay, so complex roots are complex numbers. What are complex numbers? Okay, let me just tell you this now. A complex number is a number that have two parts, okay? The real part and the imaginary part, all right? So now in complex numbers, the square root of a negative number, okay, let's say a square root of a negative a gives you ia, okay? Yes. So I'll be talking more about this when we talk about complex numbers, all right? Gives you square root of, now, in your secondary school, they might have taught you that square root of minus 1 is not possible, okay? But it is possible, just that it's a complex number. It becomes what now? I, okay? Or you can say j, all right? Now, so the kind of answer, the kind of roots that we'll have here is a complex root that have a plus ib, okay? Here a is called the real part, and B is called the imaginary part. So perhaps you would learn what we call complex numbers. Okay, first of all, a complex root is a root that a root of a complex number. Okay, now the next thing is um, what is a complex number? A complex number is a number that contains two parts: the real part and the imaginary part. Okay, so that is. Now, this is another question of this section that says, find the values of lambda for which the roots of the equation x squared minus 3 lambda plus 1x plus lambda squared minus 1 is equal to 5. Now, this is a different pattern of the equation, but watch. It said, show that find the values of x that will make this equation real, that will tell you that this equation is real. Now, see, now most students will confuse this question. Okay, remember they said real. Now, under real roots, I gave you two types. It could be real and distinct. It could be real and equal. When it's real and distinct, I told you that the roots are different. But when it's real and equal, I told you that the roots is going to be the same. But however, I told you that for real, we combine both to give you this for real. When we have real roots, okay, real roots can be b squared minus 4ac, listen now, greater than or equal to 0. Is it? You must do it like this when you say real, okay? So you see that I did not just say equal to 0. I didn't just say greater than 0, rather I said greater than or equal to 0, because when it's greater than, it is real and distinct. When it's equal to 0, it is real and equal. Okay. Now, so coming back to the equation, let's come back to the equation. I told you that before you do anything, before you allocate your values for A, before you allocate your values for B and for C, the first thing you do is to arrange your parent equation. Okay, now this is the parent equation here. The parent equation here is simply x squared minus 3 lambda plus 1 x plus lambda squared minus 1 is equal to 5 lambda. I told you this. I said make sure that there's not the right hand side has no term. Carry everything on the right hand side to the left hand side of the equation. Okay, before you allocate values for A, B, and C, it's very crucial. If you don't do it that way, you're going to get the wrong answer certainly. Okay, now so watch. Doing what I just said, we have x squared minus 3 lambda plus 1 x plus lambda squared. Now, if I bring down this 5 lambda to cross the equal to sign, it's going to give me minus 5 lambda. Then I have what now? Negative 1 in equal to 0. Okay. So at this point in time, we could simply say that our A is what is standing close to s squared as 1. Okay. Our B is going to be, now everything here is a negative 3 lambda plus 1. Now, do not make the mistake of saying that B is just this. No, remember that B is everything added to the sign, everything. Okay, so you must go alongside. Then your C is equal to lambda squared minus 5 lambda minus 1 equal to 0. Okay, now we don't need to put equal to 0 there again. Okay, so applying this equation now, we're going to apply this equation now. We're applying this equation now. So watch. So remember, it's b squared. Start with b squared. So our b is minus 3 lambda plus 1. There's a squared, b squared. Now, minus 4a is 1. Then c is lambda squared minus 5 lambda minus 1. Okay, should be equal to 0. Right? So let's expand this one again. We're going to expand this again. Okay. Now, if I expand 3 lambda plus 1 squared, it's going to be 3 lambda plus 1 times 3 lambda plus 1. Okay, so you're going to do the same thing here. Expand it. We have 3 times 3 gives you 9. So we have 9 lambda squared. Okay, 3 lambda times 1 plus 3 lambda. Then 1 times 3 lambda plus 3 lambda. 1 times 1 gives us what now? 1. So finally we have 9 lambda squared plus 6 lambda plus 1. Okay, now this is the expansion for this. Okay, this is the expansion for this. Okay, Now, so we're going to do that now. So we're placing it here. We're going to place the expansion here. We'll place it here. So it becomes 9 lambda squared plus 6 lambda plus 1 minus, if you open bracket with 4, we're going to be having minus 4 lambda squared. Then minus 4 times minus 5 lambda gives us plus 20 lambda. Minus 4 times minus 1 gives us plus 4 is equal to 0. So we're going to collect like terms here. Okay. So this 9 lambda squared will go with the 9 lambda squared. Okay. So 4 minus 4 lambda squared. So 9 lambda squared minus 4 lambda squared gives you 5 lambda squared. Then 6 lambda plus 20 lambda gives you 26 lambda. Okay. Then 1 plus 4 gives you 5. All right. This is now equal to, now you can see that we now have a quadratic equation. But remember that what we have here, remember this, what we have here is a greater than or equal to. So remember that is a greater than or equal to. So you have to make sure that you have the greater than or equal to 0. So here also is to be the greater than or equal to. Remember this, okay? Now, so what we have here is an inequality equation, okay? A special type of inequality equation that is called quadratic inequality equations, okay? Now, I will just work with the shortcut in treating this. Now, the first thing we have to just do a normal factorization, because if you check here, you see that what we have here is a quadratic function, all right? Now, but an inequality symbol is attached, which makes it a quadratic inequality, all right? Now, watch. So, first thing we do, let's factorize this normally. So how do we factorize? What are the factors? Okay, first now do I multiply 5 times 5 gives me 25. Okay, now what are the factors of 25? We have several factors of 25, okay, because 5 and 5 multiplied together will give you 25. 1 and 5, okay, 1 and 25 are factors of 25 too, okay. But of these two pairs, which of the pairs can I add or subtract to give me 26? That will obviously be 1 and 25. Okay, so it means that the factors are going to attach here becomes lambda and 25 lambda. Okay, like saying that's 1 and 25. Like I said, no, we were able to choose these, okay, because it satisfies our condition. When we add it, we can get 26, and when we multiply it, we're going to get the results we have when we multiply 5 and 5, which is 25. So our factors is 1 and 25. All right. Now, at this point, let's go. So it becomes 5 lambda squared. Okay, then plus lambda plus 25 lambda plus 5 greater than or equal to 0. Okay, so at this point, we'll do something again like this. Group. From the group, lambda is common here. So if I bring out lambda, I'll be left with 5 lambda. I'll be left with 1 here. Okay, now plus 5 is common here. So if I bring out 5, I'll be left with 5 lambda plus 1 greater than or equal to 0. So at this point, we'll be having 5 lambda plus 1, okay, into what will be left. If I bring up 5 lambda plus 1 is here, and 5 lambda plus 1 is here. So if I factorize it, we'll be left with lambda here, we'll be left with 5 here, okay, greater than or equal to 0. All right. So at this point, now what do we do? What do we do at this point? Okay, this is what we do. Now, of this term, the smallest of the term, we take the sign. That's it. The smallest of these two terms. Now, which of the two terms are smallest here? Which of the two terms is the smallest here? 5 lambda plus 1. Lambda plus 5, which is smallest. Then if I place lambda at 0 here, okay, what will be left here is 1. If I place lambda at 0, what will be left here is 5, which means that lambda plus 5 is bigger than 5 lambda plus 1. So in that case, I can say the smallest takes the sign. Okay, smallest takes the sign. All right. Then the other one takes opposite the sign. Okay, takes opposite the sign. So the smallest of them took the sign greater than or equal to, while the other one takes the reverse, opposite the sign, which is less than or equal to 0. Okay. So at this point, I can say 5 lambda is greater than or equal to minus 1. So lambda is greater than or equal to minus 1 over 5. Then we're going to say lambda is less than or equal to what now? Minus 5. Okay, so at this point, is it possible for a number to be greater than minus 1 over 5 and less than minus 5? It is not possible. Let me show it to you. Okay, let me show it to you now. Let's use here to do it. Let's use it to do it. But let's say we have a number line, okay, like this. This is a number line. Where am I going to have? This is the 0, okay, and on this side we have positive numbers, and on this side we have negative numbers, okay. Now, minus 1 over 5 is going to be here, minus 1 over 5, okay, and minus 5 should go further, so we have minus 5. So in the first case, x is greater than minus 1 over 5, which means x is greater than or equal to, is moving like this. But in this second case, x is less than or equal to 5, which means it is going like this. So I cannot combine this inequality. It is best that I leave my answers like this. Okay. Now, what I just did now will be fully treated, okay, under the topic called inequalities in my YouTube channel. Okay. Just try to subscribe to my YouTube channel, the Calculus. Okay, the Calculus Academy. Okay.